Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In the last video, we looked at doing comparisons between values and the syntax for doing those that we could use in our if expressions and statements to do conditional logic. Having simple comparisons is useful, but a lot of times you need to build larger logical expressions. You need to be able to say more than just you're greater than one thing or less than another. And in order to build larger Boolean expressions, we need to use Boolean logic. And there are a number of operators that are part of Boolean logic. And to illustrate this, I want to use the example of checking to see whether or not a point is inside of a rectangle. So let's go ahead and let's create a script for this. We'll start off with actually print. We need to have the user input values for the point. Val, we'll call it px for the point x. We'll copy two lines and paste them, change it to a y. Now we need to read in the rectangle. How do you specify the bounds of a rectangle? Now, one thing, we're not going to allow the rectangle to be rotated. It has to be aligned along x and y axes. And two ways that we could do this would be to have a center and a width and a height, or we can, kind of the more standard way to do it is to specify the top left corner along with the width and the height, or the minimum value for x and y along with the width and the height. I'm going to go with that second form here. There are some other applications for which it's nice to have the center point instead of the minimum x and y. But we'll go with the minimum for this one. Either one would work quite well for what we're doing here. So input the minimum x value for the rectangle. We can copy that, change it to be a y, and now we need a width and a height. Now, we have these 6 values, and this leads to the question of how do we know if the point is inside of the rectangle? Well, this is one of these situations where when I'm teaching students in class and I draw a rectangle and a point up on the whiteboard and I say, is the rectangle inside? And of course the answer to them is obvious. You just look and you're like, yes, it's inside, or no, it's not. But when you get it in this format and you have 6 numbers here that you have to deal with, you really have to break the problem down. And this is one of these things that programming is good for teaching you how to do, is the fact that so many problems are just immediately obvious to us as humans when we look at things, that we don't really think about the logic that's going into that. So let's go ahead, and I'm actually going to declare a variable. I want to break this problem into 2 pieces, because it turns out that determining whether you are inside of a rectangle actually comes down to determining whether you are inside of the x bounds and whether you are inside of the y bounds. And we can separate those 2 pieces and then use the combined value. So I'm going to make a variable called inside x. And basically what I want to do is I want to be able to say that px is in between the value of rx and rx plus width. Okay, now in math, you might be tempted to do something like that. In fact, that's how you would say that in math. Unfortunately, that is not going to be happy for Scala, and the reason is because what Scala sees is this, and so this right here with this less than gives you back a Boolean, and so it will be either true or false. And that means that you're saying that true, either you're saying true is less than some number or false is less than some number, neither of which makes any sense at all. Okay. This right here in math is actually just a shorthand for saying that px is both less than, or that rx is less than px, and at the same time px is less than rx plus width. And so that's what we want to say here. That word and winds up being very significant. It is one of our Boolean operators. Okay, the and operator is our first Boolean operator that we'll look at. And we type it in Scala with two ampersands. Okay, so and is the Boolean and operator. And what that means, it's very much the same thing that you mean when you say it in English. That if, I'll go outside if it is sunny and the temperature is below 95. Well, if either one of those is false, you're not going to go outside. So the whole thing is only true when both the first and the second part are true. Okay. I can copy that. I can paste it. And make another version for y. And it turns out that you're inside the rectangle. And I will just print this out. You're inside the rectangle only in the situation when you are inside in x and you're inside in y. So this particular example only used the and operator. Okay, we needed it to be all four of these things. You have to be the px has to be greater than rx and ry, and it also has to be less than those values plus the width and the height in order for this to work. And we could have written it as one long Boolean expression with four different terms here. Breaking it up into different variables just makes it a little bit easier to read in this case. Just to make sure, we should run that. How about the point 1, 1 inside of the rectangle 0, 0, 2, 2? And the answer is, of course, true. If we run it again and we go with the point 10, 10 inside of 0, 0, 2, 2, we get a false. So that works. Okay, so that demonstrates the AND operator. Another operator that we use when we are doing Boolean logic is the OR operator. I will demonstrate this one just in the REPL. So I want to say, for example, I want to check all, actually, I guess, no, let's do CP point in rect to point outside rect. Okay, we still enter all these, but now we want to check to see if you are outside of the rectangle. Well, so we should change our variables here. And let's think about this. So when are you outside in the x-coordinate? Well, you would need to be you're outside in the x-coordinate if either Rx is greater than px, or if px is greater than rx plus width. So now instead of having a single range where you're between two things, you could be on one side or on the other. So how do we put an or here? The or operator in Scala is written as two pipes. Remember, we saw these pipes before. On most keyboards, they are on the key above the enter, and you have to use shift to get to it. We use these for sending information from one process to another. Two pipes in a row is how we say a logical or in Scala. And we can change this as well. And now here, you are outside if you are outside of either the x or the y. Now, something to note about this or. This or is not quite the same as the one that you use in English. This is what's called an inclusive or. And in English, when you say the word or, most of the time you mean an exclusive or. To give you an example of this, consider when you were a child and your parents would give you the option of having cookies or cake. Well, the correct answer to that was never both. That is because in English, the exclusive or says that it either has to be the first thing or it has to be the second thing, but it can't be both. The or here is actually an inclusive or. And when you're using logic, it's far more common to use the inclusive or than the exclusive or. And the inclusive or says that it could be this one, or it could be this one, or it could be both. Okay, I'm quite happy either way. You know, that would be, so as a child, you wish your parents used the inclusive or, because then you could have had the cookies and the cake and everything would have been happy. The statement would have still been true. You can write an exclusive or in Scala. The exclusive or in Scala is written as a caret. So true, XOR, exclusive or true, is false. In other words, you can't have both the cookies and the cake. You can have the cookies but not the cake, or you can have no cookies but have cake. The interesting thing to note is when your parents said you could have the cookies or the cake, technically they didn't give you the option of having neither. Because of the way the exclusive or works. Whereas if we were to do these same things with the normal or, and just to make it clear, most of the time in your programs, you're going to use this version of or. You are going to use the two pipes and not the caret, just because that's how it works. So you'll note that here, true or true is still true. True, false, false, true. The only one that's false is false, false. Whereas with and, the only one that's true is true and true. There's one other Boolean operator that's worth mentioning because you use it a fair bit, and that is not. When we talked about comparisons, we said that not equal was bang equal. Well, it turns out that saying not is just a bang. So not true should be false, and not false should be true. Not 34 less than 25. Well, 34 is greater than 25, so this is false, and when we say not that, we get true. You can combine not, or, and, technically XOR, to make long and complex statements in Boolean logic, and so that you can put them inside of if statements so that you can act only in very specific situations. The book runs through examples of where you're doing a theme park and you're charging prices for things. And so you can build up whatever complexity of statements you want by putting these things together in appropriate ways. So that's it for this video. We'll come back later. We'll look at two other applications of using if to round out the chapter.